Okay, ladies and gentlemen, welcome to lesson 2.2. This is solving inequalities using addition and subtraction. You're going to learn how to solve inequalities using addition, then you will learn solving inequalities using subtraction, and we will use these properties to solve some real-life inequality problems. So what is the property for addition? Well, exactly the same as in equations. If you add the same number to each side of an inequality this time, it produces an equivalent inequality. So you don't change it. What it means is it's still going to be true. So like looking at the numbers, -3 is less than less than 2. That's true, right? -3 is less than 2. Well, if we add 4 to -3 and we add 4 to 2, what we get is 1 is less than 6, and 1 is less than 6. Therefore, it's true. Same thing happens if you're looking at -3 greater than or equal to -10. -3 is greater than -10. If you add 3 to both sides, you get 0 is greater than -7, greater than or equal to, and it is. So we have this little visual that kind of shows us. All we're really doing is kind of shifting it on the number line when we're adding, because we're adding the exact same quantity to both of the original numbers, and what we get is also true. So that's the whole meaning of this. So let's go ahead and do this. So when we solve inequalities, we get to use the exact, same steps that we solve for equations. Just don't forget to keep the inequality symbol and not make any changes. So for the first one, x minus 3 is less than -4. You want to add 3 to both sides. You will get, so this cancels out, x is less than -1. So when you're making the number line, you have a blank number line because we want to graph our solution. You can just put a few numbers on there. You don't have to fill it all out. The main thing you want to make sure is that you definitely have numbers on the left and right of the number that you're graphing. And in this case, that's the -1. And it's going to be an open circle at -1. Every number that will make this statement true, x is less than -1, will all fall to the left, to the left of -1. So meaning -2 is less than -1, or -3 is less than -1. You might want to substitute in a few of those values to make sure that it makes sense. Moving on to 2. -3 is greater than -3 plus h. So we have to start on the right-hand side, and we need the additive inverse. So I know some of you may think, oh, we have to subtract because there's a positive or a plus sign, and it's addition. We're undoing addition, but we have to make sure that what we get is 0 with this -3. We need it to disappear. So we're going to add 3 to both sides. It's called the additive inverse. And adding 3 to both sides actually does cancel that out. What it's equal to is 0, so 0 is greater than h. All right, now here's where the tricky part comes in. Some of you may be perfectly capable of drawing this graph correctly, just like this. I kind of hinted to the way to know which way the arrow points if you have the variable on the left. Like in number 1, if you look up at number 1, x is less than -1, and that less than symbol kind of points to the left, and notice that our graph points to the left. Well, that's not true here. Because it looks like the arrow's pointing to the right, but this graph will not point to the right. So one thing you could do is, if you wanted to, make almost like a reflection, sort of, so to speak. And it's like you flip the whole thing over, or just look and see what side of the inequality symbol does h see, and it sees that less than symbol. So if I reversed it, I would have to reverse and put h on the left. It becomes h is less than 0. Okay, so be very careful about that you cannot interchange the 0, and these are zeros, not O's. You cannot interchange those two things around the inequality symbol. They each have to remain where they are. So we're just going to put a couple numbers on either side of 0. And then we have an open circle again, and it goes left because all the numbers less than 0. Oh my, that's a crazy arrowhead. All the numbers less than 0 will make it true. -1 is less than 0, -2, and so on and so forth. So make sure you understand what just happened there. I'm going to clear this, and we'll move on. So now we have the subtraction property. So subtracting the same number from each side produces an equivalent inequality. So -3 minus 5 is -8. 1 minus 5 is -4. -8 is less than or equal to -4, just like -3 is less than or equal to +1. So we have this true statement that occurs, and so here is showing the blue arrows on top going to the left. We're just shifting those two numbers to the left, but by the same quantity. That's what subtraction does. All right, so number 5 and 6, I've kind of skipped ahead. So we're kind of jumping in here and doing some multi-step or simplifying first. So we have 12 is less than or equal to 4c minus 3c plus 10. We have some common or like terms here that we want to combine first and rewrite it. We have less than or equal to c plus 10. Now we just have a one step, so we'll subtract 10 from both sides, and we'll get 2 is less than or equal to c. Or you could, flip it back, reflect it, however you want to call it, and say c is greater than or equal to 2, but we know that in this case the arrow is going to point to the right. So let's put our 0 over here. 1, 2, 3, -1, -2. Sorry that I mumble sometimes. All right, in order to be able to get this at +2, look at that. Oh, I did a wonderful good dot on 2, and it's solid. It is solid because of that little half equal sign that's under the greater than symbol. That means greater than or equal to, or if we're looking at the first one, 2 was less than or equal to c, so 2 has to be the smallest number. It goes to the right. Oh, I'm so good at that. Love being able to change the thickness of my pen. Okay, moving on to 6. 15 minus 7p plus 8p. So again, we want to combine like terms. We have like terms on the left of the p terms, the variable, and on the right we have these two constants that we can combine together on the right. So 15 plus p is greater than 13. Okay, and then we want to simply solve for p, so that means we will be subtracting 15 on both sides, and we'll end up with p is greater than -2. So I need to box that in. I do like to circle my answers and box them in, but okay. So if we put a 0, 1, 2, -1, -2, keep going to -3, -4, you don't have to do all of them. Then we're going to want to draw our graph, and again we'll look at this and we'll say, is that an open or a closed circle? And this time it's going to be a open circle, and it's open at -2. So now that I've drawn a really thick line, I'll have to make a really big circle. Okay, and since it's greater than all the numbers that point to the right. Okay. Finally, we have our word problem. So in this case, we're going to write a inequality statement for the first part. Oops, sorry. Okay, we have you have $15 to spend on groceries. That's like our total money that we have in our pocket or whatever it may be. You have $12.25 worth of groceries already in your cart. So we're going to write an inequality that represents how much more money M we can spend on groceries. So it would be M plus the $12.25 we have in our cart, and this would be, so our total is 15. That's the biggest number we can have, right? So we could spend less than 15, but we could also spend exactly 15. Wouldn't that be awesome if you could do that? Because they're going to charge tax. But so we have M plus 12.25 or 12.25, 12 and 25 hundredths to be mathematically correct, is less than or equal to 15. And then the second one was just solve the inequality. So we'll just kind of come up here and say, okay, we're subtracting 12.25 from each side. So that's going to give us M is less than or equal to 2 $2.75. We can only add $2.75 more of groceries to our cart if we already have $12.25 of groceries in our cart, so that we don't go over the $15 we have to spend on groceries for the day. Alrighty, that should be it. So this was a nice short video. Until next time.